Alright guys, obviously I am not here today, so I wanted to make you a video kind of going through some more strategies for simplifying these identities, these expressions, excuse me. So let's look at this right here. There is a delta math right here. Told you guys about it in class. It's going to open literally at midnight tonight. So it opens today. When you're seeing this, it already opened at midnight, and it's due. I'm gonna make it due on Sunday. That's Sunday, I believe. Yep, Sunday at 11:59 p.m. Don't wait till the last minute. Be 100% honest. Don't wait till the last minute. You probably won't do it if you do that. Brain questions if you need help. I'll probably be back on Thursday. Alright. So yeah, complete that edit. Alright, so doesn't matter, get that done. Now, in classes today, if you weren't here, man, you missed a good bit. I know some of y'all had to go do whatever, but not my problem. Look, listen, you got a few identities here. We got the reciprocal identities, the quotient identities, and the Pythagorean identities. We rewrote a lot of these to utilize them. Hopefully you did that in class when we did them. Co-function identities and odd and even identities, okay? So when we look at what we have to work on today, you should see these problems right here. Alright, so what I want to do is I just want to talk through these. I'm not going to do all these. Right? I'm going to talk through a few of them. And I took some time to simplify these just so it is not that daunting, and hopefully it makes sense. So I'll start off with, I'll leave that. Yeah, let's do that one. So this one, remember one thing that helpful hint I gave you in class, if you remember, simplify as much as possible. All right, remember, try to simplify to sine and cosine. All right, I think that's a helpful hint, especially with a lot of these that don't have addition and subtraction. I think that's the easiest way to go with these. Like, for example, cosecant. All right, cosecant, if you look at your table, right, cosecant is if you look at reciprocal identity, all right, cosecant would be the same thing as 1 over sine. All right, so right here, I'm going to rewrite the top right here as 1 over sine. And then the bottom cotangent, right, if I look at, let's say I look here at the the quotient identity. Cotangent is cosine over sine. Alright, but some of y'all, most of y'all know that. Alright, at times, guys, excuse me, I'll forget to write the X. Alright, it's okay. Alright, so anyway, I got a fraction over a fraction, so I'm going to keep change flip. Meaning I'm going to keep this top. I'm going to change this division right here to multiplication. And then I'm going to flip this bottom to have sine of x over cosine of x. All right, we flip that. So now it's up here. So now if you look, you'll see that sine cancels out. So you're left with 1 over cosine of x. And then 1 over cosine of x. Again, you can look back at your table. Cosine of x right here is secant. All right, secant x. So there we go. All right, so this equals secant x. Same logic will apply right here. All right, you will try to simplify as much as possible to get into sine and cosine. Like for example, secant. I can rewrite secant as 1 over cosine. All right, and again, I'm using all these I'm getting from So a lot of these I'm getting from, the notes I gave you yesterday. So hopefully you keep up with those. All right, if not, get a blue sheet. All right. Anyway, so realistically, I could just multiply straight across. 1 times sine is sine, and cosine times sine over cosine is cosine sine all over cosine, right? So if you look, that's division, that cancels. So I'm left with sine over sine, which equals 1. All right, sine over sine, which is 1. All right. It's so many different ways you could do this. All right, all these. Somebody might have thought, oh, well, before I even touch secant, sine is sine over 1, right? Tangent would be sine over cosine, right? If I took this, all right, and simplified this, keep, change, flip, I'll end up multiplying by the reciprocal of this, right? The signs will cancel, so I have cosine over 1, right? So then I now, and look, this is only this portion. So now this portion equals cosine over 1. So now if I take secant, right, I take secant, which is 1 over cosine, and multiply by cosine over 1. Again, everything cancels. I'm left with just 1 over 1, which is 1. You see what I'm saying? So there's several ways you can do this. It's just a matter of where you start. I'm going to leave that there. You just got to pick a strategy and go with it. Because what one person's going to do, the person next to you might not think to start there. You know, just keep going. Let's look at this one. A couple different ways we can do this one. These are squared, but specifically, let's look at that. 1 minus sine squared of theta. If you remember, there's a reciprocal identity. No, there's a Pythagorean identity. Right here, sine squared of theta plus cosine squared of theta. Well, I can rewrite this. All right, I'm going to isolate cosine. And how I'm going to do that is I'm going to subtract sine of theta on both sides. Sine squared of theta. So I'm left with cosine squared of theta equals 1 minus sine squared of theta. All right. And the reason I did this is because now that's something we see on our paper. This is manipulation. I'm rewriting this to fit what I need, which I need this. All right, because that's on the equation that we just had. Right there, 1 minus sine squared. Okay. So what you would do with something like this is, since 1 minus sine squared of theta equals cosine squared of theta, all right, I'm going to substitute that in place. I'm going to substitute, right, where was I? Right, wrong one. Right here. I'm going to substitute right here, cosine squared of theta. All right, this shows you how, or cosine squared of x, since it's an x. This should be an x. I showed you how this is equal to that. Okay, so now I have secant squared of x times cosine squared of x. All right, well, if you remember the reciprocal identity, what's the inverse of secant squared, right? Well, it's the same thing as the inverse of secant. All right, please don't be one of the people that don't get it, man. Yo, this is on YouTube. Go watch it. See how secant of theta equals 1 over cosine? Well, if I had secant squared of theta, that's the same thing as 1 over cosine squared of theta. All right, the power still applies. All right, the power still applies. Don't get freaked out. Okay, so secant squared of theta equals 1 over cosine squared of theta. Okay, you can do this. I'm telling you, you can do this. You just gotta practice. You gotta practice. So right here, we said that secant squared of theta is 1 over cosine squared of theta times cosine squared of theta, or x. Here, let's put x. I'm sorry, y'all. I keep doing that. I keep mixing them up. It's just because I just looked at it over there. But anyway, we'll put that over 1. So now, if you look, that cancels with that. I'm left with 1 over 1, which is 1. Okay. So this equals 1. Okay. This one, right? Look at your look right here at your co-function identities, right? You would just substitute that in place. Sine of power 2 right here. That right there, sine of power 2 minus theta equals cosine of theta. So you would just put cosine of theta right there. And then that cosecant is 1 over sine. So you know what cosine over sine. See, look, that's cosine. That right there is 1 over sine, right? I know I'm doing this kind of fast, but I'm just trying to give you something to get you started. So if you multiply straight across, because that's how you multiply straight across, you get cosine x over sine of x, which is cotangent x. All right. If you look, this is on your quotient identity. Quotient identity. Sine x over cosine. Cosine x over sine x, excuse me. That's your quotient identity. See? Cosine x over sine x. Yeah. Right there. Alright. Even this one, right? Think about that bottom. Rewrite that bottom. Alright, look at that bottom right there. Cotangent squared of x plus 1. Alright, you can go here to the Pythagorean identity right there and manipulate this, alright, to be what you want it to be, if it's not already that, right? So we got 1 over cotangent squared of x plus 1. Well, we know what 1 plus cotangent squared is. Alright, I know this is written as, you see it written down on that paper as cotangent squared of theta plus 1. Guys, it's the same thing, right? If I had 2 plus 1, that's 3. That's the same thing as 1 plus 2, it's still 3, right? So this is the same thing as that. So we know that equals cosecant squared. All right, anytime you add cotangent squared plus 1, or 1 plus cotangent squared, you're going to get cosecant squared. All right, so we're going to substitute that in. I'm telling you, you can do this. All right, you don't have to freak out. Right? So now, 1 over cosecant, we know what that identity is. All right, and all this comes from the sheet. I'm telling you, 1 over cosecant. 1 over cosecant is right here. All right, but we have 1 over cosecant squared. Well, what would that be? Right? Sine squared. Remember, the exponent travels. So it's just sine squared. Sine squared. Alright. Now, real quick, man, I don't know if I clarified this for you yesterday. Hopefully I did, but if I didn't, alright, let me do it for you. Understand that, like, for example, I'll use sine. Sine of x times sine of x. Alright, it's sine squared of x. This is what's being squared. Understand this is an internal function of this actual identity. Alright, so it's still an internal function. Alright. Don't practice this right here, sine times sine, sine x times sine x, and sine x squared. Guys, this is not x squared. Alright, it is sine times sine. I'm just throwing it out there because I had that question come up in class today, and I just want to make sure I clarify that for somebody. Alright. Yeah, common denominators. This is exactly like, if you look at the notes, what we did on the notes. That's exactly like this one right here, number 8. All right, so let that be your guide right there, number 8. Okay. I know that was one of the more difficult ones on day 1, but we'll be all right. All right, now it says factor each expression and use fundamental identities to simplify. Okay, so factor. Factoring is exactly, if you were to factor anything, you factor, you know? So I'll start with this one. Right here I can factor out a cotangent squared, because if you look on both sides of this negative or this minus sign, you have a cotangent, right? So if I factor out a cotangent squared of x, right here, that would be 1, right? Because cotangent squared of x times 1 is cotangent squared of x. And right here, you'll be left with just cosine squared of x. And check yourself. Cotangent squared times 1 is cotangent squared. Cotangent squared times negative cosine squared of x is cotangent squared cosine squared of x. See? Now, cotangent squared of x, we know what this is. We know what that is. All right. If you go back and look, wrong way. If you go back and look at your Pythagorean identities, right, oh, wrong page, right here. All right. I see cosine squared, so it has something to do with this one. Well, we're looking for 1 minus cosine squared, right? Well, how can I make this look like that? Well, easy. Subtract cosine squared of theta. Right? So I'm left with sine squared equals 1 minus cosine squared of theta. So there it is right there. Right? So what can I substitute in that place? In place of this, sine squared, I'm going to plug that in place of that. Right? So that is going to be sine squared. Now, remember the quotient identity. Cotangent is cosine squared of x over sine squared of x. And we still have times sine squared of x. Do you see what happens now? Hopefully you do. The sine will cancel out. I'm left with cosine squared x over 1, which is cosine squared of x. Okay, this one right here. Remember how we talked about x plus 3 times x minus 3? Sorry, that was my alarm. And that was x squared minus 9, right? X times, well, it's when you have the same polynomial but different signs, or different function, different operation signs. All right, x times x is x squared, 3 times negative 3 is negative 3. This is the difference of 2 squares. Well, how do you undo this? Just factor those two. All right, x squared is x times x, and negative 9 is 3 times negative 3. All right, even if I had x squared minus 16, well, that'll give me x times x, right? And then how do you get negative 16? Negative 4 and positive 4. Now, why are you doing this, Coach Moore? I'm doing this so you can see this right here. Cosecant squared of x minus 1. All right. I know you're thinking, oh, we can use Pythagorean, to rewrite this and get it. You're like, wait. These look similar. They look similar. And what I know about this top is that's a perfect square because I see the square. But 1 is a perfect square as well. So that is a difference of perfect squares. So I'm going to simplify that top part by factoring this. All right, remember how we just did x plus 3, x minus 3, right? Well, I undid this, x times x, negative 3 times 3. So how would you get cosecant squared? Cosecant times cosecant. Oops. Cosecant times cosecant. And how do you get negative 1? Positive 1 times negative 1. Right? And we have that all over cosecant x minus 1. Now, do you see anything? Yeah, I do. You see how those are the same as that? That's the same polynomial right here. Let me cancel that out. Or is it binomial? Same binomial. I'm going to cancel that out. So I'm left with just this. You see what I'm saying? Alright, hopefully, again, go look on YouTube and at the video I posted if you need more clarity on these. Also, that delta math, man, that practice is something. It helps. I promise you it helps. Man, we can go on and on with all these, right? I can simplify this one. Don't be discouraged by all those values. Alright, simplify it. You can simplify this, right? What can you factor out? These are to the 4th. These are to the 4th, but you can simplify it the same exact way. I promise you can. don't believe me, think about it. These are squares. These are perfect squares. And to the fourth, they're perfect squares. This is a perfect square. This is a perfect square. The difference is 2 squares. So how do you get sine to the fourth? Sine squared times sine squared. How do you get negative cosine to the fourth? Negative cosine squared times positive cosine squared. Right? See how I write the x and sometimes I don't. Sorry about that. Alright. So, well, what do we know about sine squared plus cosine squared? Or sine squared minus sine squared? Well, let's go see, Coach Moore. What do we know about that? If I go to my Pythagorean theorem, identity. Let me erase that so you can see it clearly. Sine squared plus cosine squared. Oh, I have that. I also know what it equals, right? So that's 1. So let's go back to it. This sine squared plus cosine squared is 1. Now I have sine squared of x minus cosine squared of x. Alright. So 1 times that is just that. So that's gone, right? 1 times this is this. Now, can I simplify that in? And that's the hint I'm going to give you. Can you simplify that anymore? You know? I'm going to let you think about it. I'll let you think about it. Let me know. This one. Can we factor this? Are there any trig identities we see present that we could use to our benefit for later? You know, can I apply this factoring method right here? Probably not, because that's odd. That's a cube. All right, you see that? That's a cube. That's a square. Okay. So what factoring technique can we use right here? There is, you got the cubes. How you factor cubes? Are there any other trig identities you can use? Absolutely. You just got to figure it out. Down here, same thing. Can you factor out anything? Absolutely. Absolutely. I'm going to let y'all work on those. Let's jump down here. Rewrite the expression so that it is not in fractional form. Excuse me. Alright, these are a little bit simpler. Okay. I think starting off with 1 minus sine squared of x. We can rewrite that. We did that earlier in this video. Alright. Again, we're looking for 1 minus sine squared of x, right? Well, can I get that from here? Yes, absolutely. Move that over here. It's going to be negative. Right? So sine squared of x equals 1 minus sine squared of x, equals cosine squared of x, right? Or cosine squared of x. So we'll go back and plug that in, right? This is, cosine. Alright. And then this one right here, can we find that? Cosecant squared of x minus 1. Let's go back to our Pythagorean identities. Was that cosine or cosecant? Cotangent. No, I'm on the wrong one. Cosecant. That's cosecant minus 1. So yeah, we can get that right. Minus 1 on both sides. Right? Cotangent squared of theta equals cosecant squared of theta minus 1. So that's what we're looking for. So we know that equals cotangent squared of theta. See? You just rewrite these to fit your equation, man. Alright, so from there, how would you reduce this? Well, we know cosine squared of x over 1, right? Keep this. I'm going to convert that right there to cosine squared of x over sine squared of x. That's the bottom. Alright, now this. This is right here. But if you rewrite this, here, let me just rewrite it. So I rewrote the whole thing for you. Now keep the top, change from division to multiplication, and then flip this bottom. Here's the bottom. Flip that. Right? You see that cancels? So I'm left with just of x, sine squared of x. So this simplifies to that. Man, you can just keep going, man. I promise you can keep going. Right here, a little more rigor. Ooh, that one there. Rewrite that top. Rewrite this top, all right? Sine squared of x. You can make that look like that, okay? This one, there's a couple different ways you can do this one. There's a couple different ways to do all of them. How would you do it? Maybe rewriting denominators and saying that I can get rid of things. Not a bad idea. And here's what I mean. 3 is 3. Secant is 1 over cosine. Tangent is sine over cosine. So now I have common denominators, right? So I have 3. And again, this is for the bottom. 1 minus sine over cosine, right? I have common denominators, right? Now, can I simplify this? Yeah, you can keep change flip. So you get 3 times the bottom all over 1 minus sine, right? Now, can we reduce this in any way? Just keep looking for opportunities. You can. All right, you can. That simplifies it even more. Nah, that's it on that one. This one doesn't. This one won't leave fractional form. Can you simplify that? Nah, this one don't simplify anymore because I can't simplify that. This is not typed right. This should be squared. Then we can do it further. My fault. So we're gonna omit that. So now you only got 19 problems. All right, we did 1, 2, 3, 4, 5. We did that twice. 6, 7, 7.5. Because I didn't conclude this for you. You can finish that. So we did 7.5 problems out of 19. So you can finish the rest. Okay, so y'all finish this practice. Please practice. Hey yo, let me throw one more helpful handout. Like, see something like this? Maybe this will help you if you looked at it like 2x squared, see 2x squared plus 3x minus 3. Maybe that'll help you. If you know how to factor that. That's a quadratic. You should know how to factor that. Recalculate. You gotta know how to factor. So you can do that. All right, but here, let's spend some time on these as practice. There's also Delta Math. Don't forget, it is open now. If you're looking at this, Delta Math is open. And I will see you tomorrow. Bring questions. Okay, bring questions because I'm definitely building up on this stuff. All right. See y'all on Thursday. Peace.